Ever wondered why the stars shine or how your phone works? Welcome, dear friends, to the captivating world of physics. This is the science that breathes life into the universe, the language that nature speaks. From the twinkling stars billions of miles away to the device you're using right now, physics is at play. Physics is the study of matter, that's everything around you, and energy, the force that sets matter into motion. It's about the interactions between the two, painting a picture of the universe and its wonders. Every time you toss a ball, flick a switch, or gaze at the night sky, you're witnessing the laws of physics in action. It's in the air we breathe, the ground beneath our feet, and even in the light that guides us, and it doesn't stop there. Physics is in the invisible spaces, the forces that hold the universe together. In the next few minutes, we will delve deeper into some fascinating areas of physics. Gravity, an invisible force that keeps us grounded, but what exactly is it? Well, imagine you're holding a ripe apple. You let go, and it falls straight to the ground. Why didn't it go up, or sideways, or in circles? That's gravity at work. It's the force that pulls objects towards each other. In the case of the apple, it's the force that pulls the apple towards the center of the Earth. Now let's take this concept a step further. How about the moon orbiting the Earth, or the Earth orbiting the sun? Why don't they just fly off into space? Once again, it's all because of gravity. Every object in the universe, no matter how big or small, exerts a gravitational pull on every other object. This pull is stronger the closer objects are to each other, and weaker the further they are apart. The Earth pulls on the moon and keeps it in its orbit, just like it pulls the apple towards its center. And the sun, being much larger and having a greater mass than the Earth, pulls the Earth and keeps it in its orbit. But gravity doesn't just keep things in orbit. It also gives weight to physical objects and causes the ocean tides. It's the reason we can't jump off the Earth and fly into space. It's why we feel heavier when we're on the ground floor of a building compared to when we're on the top floor. Gravity is an ever-present force, shaping and influencing our lives and the universe in ways we often take for granted. From the smallest particles to the most massive galaxies, gravity is the glue that holds the universe together. So now you know a little more about this incredible force. It's not just some abstract concept, but a real, tangible thing that affects everything around us. So next time you drop something, remember it's not just falling, it's being pulled by an unseen force. Light, something so common yet so complex. Ever wondered what it is made of? Picture this. You're standing in a room, the switch flicks on, and suddenly the room is awash with brightness. But what exactly is happening? What is this thing we call light? Well, in the simplest of terms, light is a form of energy, a type of electromagnetic radiation to be precise. But here's where it gets interesting. Light is made up of tiny packets of energy called photons. These photons travel in a wave-like pattern at an unimaginably fast speed, about 300,000 kilometers per second. Now, let's delve a bit deeper into how light behaves. You see, light doesn't just travel in a straight line and hit whatever is in its path. It can do three things. It can be reflected, refracted, or absorbed. When light hits a smooth surface, like a mirror, it bounces back. This is what we call reflection. It's the reason why you can see your own reflection in the mirror. The light from your body hits the mirror, bounces back, and reaches your eyes, allowing you to see yourself. Refraction, on the other hand, is what happens when light changes direction as it passes from one medium to another, say from air into water. This is why a straw seems bent when you put it in a glass of water. And finally, absorption. This is when objects take in the light's energy instead of reflecting or refracting it. It's why a black t-shirt feels hotter in the sun than a white one. It's absorbing more of the sun's light energy. So, you see, light is not just about illumination. It's a fascinating play of particles, a dance of energy that shapes our perception of the world around us. So, light is not just illumination, it's a fascinating play of particles. Quantum mechanics, a term that sounds intimidating, but is it really? Picture this. You're at a party and you're simultaneously in the kitchen snagging appetizers, on the dance floor busting moves, and on the patio stargazing. Sounds impossible, right? Welcome to the world of quantum mechanics, where the impossible is everyday reality. Quantum mechanics is the branch of physics that delves into the world of the very small. We're talking about atoms and subatomic particles. It's a realm where the conventional laws of physics that govern our everyday world don't apply. Instead, we enter a realm of probabilities. You see, a particle in the quantum world isn't just in one place at one time. It can be in multiple places at the same time. This is known as the principle of superposition. It's like being at several places at the party all at once. Furthermore, particles can also be linked through a phenomenon called entanglement. Even when separated by large distances, a change in one particle will instantaneously affect its entangled partner, no matter how far apart they are. Imagine if you suddenly started doing the robot on the dance floor, and your friend on the patio mimicked you at the exact same moment. That's quantum entanglement. Quantum mechanics also introduces the concept of wave-particle duality. Here, particles can behave both as particles and as waves. Picture this. You're both grooving to the beat on the dance floor and rippling out like sound waves from the speakers. Now, all of these might sound like a science fiction movie plot, but they're the realities in the quantum world. Quantum mechanics is a field that's still full of questions and mysteries, but one thing's for sure. It's a fascinating world that challenges our understanding of reality. In the quantum world, things are not as they seem. It's a world of probabilities. Electromagnetism, a force that powers our daily lives, but what does it mean? Let's dive into this captivating phenomenon that's so integral to our world. Electromagnetism is a branch of physics that studies the relationship between electricity and magnetism. It's a fundamental force of nature as essential as gravity, and it's everywhere around us. But what's unique about electromagnetism is that it's the cornerstone of our modern technology. Imagine electricity and magnetism as two sides of the same coin. They are different, yet they are interconnected. When an electric charge is in motion, it creates a magnetic field. Conversely, a changing magnetic field can induce an electric current. This reciprocal relationship is the essence of electromagnetism. Now let's consider some applications of electromagnetism in our everyday life. Ever wondered how an electric motor works? The principle involved is electromagnetism. Electric motors, present in everything from your car to your kitchen blender, work by converting electric energy into mechanical energy. This conversion is possible due to the magnetic field generated by the electric current. Another classic example is the humble speaker in your audio devices. The speaker converts electrical signals into sound waves, again thanks to electromagnetism. As the electric current flows through the coil in the speaker, it creates a magnetic field that interacts with another permanent magnet. This causes the coil to vibrate, producing sound. Even the medical field benefits from electromagnetism. MRI machines used for detailed imaging of the body's internal structures rely on strong magnetic fields and radio waves, both products of electromagnetism. Electromagnetism has a profound impact on our lives, whether we realize it or not. It powers our homes, propels our vehicles, enables communication, and even helps diagnose our health conditions. Indeed, the wonder of electromagnetism is that it's not just a scientific concept. It's a vital part of our world, shaping our lives in countless ways. So, the next time you flip on a light switch or listen to your favorite song, remember, you're experiencing the magic of electromagnetism. Without electromagnetism, our lives would be significantly different. Physics, a field that never ceases to amaze. As we journeyed today, we delved into the magic of gravity, that invisible force keeping us grounded, yet propelling us to explore the cosmos. We unveiled the mystery of light, a phenomenon both a particle and a wave, illuminating our world and beyond. We stepped into the intriguing world of quantum mechanics, where particles can be in two places at once, and uncertainty is the only certainty. And we marveled at the wonder of electromagnetism, the force that keeps our modern world running. These concepts, as complex as they seem, are fundamental in understanding the world around us, from the smallest atom to the vast universe. And that's the beauty of physics. It helps us comprehend the complexities of the universe, revealing the intricate dance of matter and energy. So keep questioning, keep exploring, because the world of physics is full of wonders waiting to be discovered.